doesn't. Okay, so let's graph x squared minus 1. X squared minus 1. Yay. What's the y-intercept of this graph? Y-intercept would be -1. Set x to 0. 0 squared minus 1. So it's -1 is the y-intercept. You can actually even tell it is in vertex form. The vertex is actually at 0, -1, right? That is the vertex. The a value is 1. Do you remember this? No? And the a value tells you the general shape of the graph. So it has the shape of the x squared, where we go 1 over, 1 up. 2 over, how many up? Nope. Think of x squared. 4 up. So at +3. To the left, 4 up. 3 over would be? 3 over would be how many up? 3 squared. 9. So 3 over 9 up would bring you to +8. I'll make this larger for you guys. How big? Is this okay? Or larger? Could you look at your graphing calculators to sketch this? Probably could. What's the x-intercept? Where are they at? 1 and -1. Okay. We're going to graph now the absolute value of x squared minus 1. Let's just take what we learned and make a prediction. Give a prediction of what's going to happen when we take the absolute value. What it's going to look like. Is the domain going to change? What the heck? Did you graph it? Cheater. Okay, graph it. See what it looks like. It shouldn't be surprising. Okay, so absolute value. Remember, how do we get to absolute value in our calculator?
Math right 1.
Math right 1. Abs. I need some of those. Okay, x squared minus 1. Push, graph, and look at this.
No.
Is that crazy or not? It's not crazy, because what does an absolute value do? Yeah, so anything that's positive stays positive. All of this above the x-axis is already positive. It stays where it's at. Anything below the x-axis will become above the x-axis. Right? So really, no surprise. What stays the same is all these points here. 3, and then the 8. 3, 8. Okay, that part stays the same, but now my vertex, instead of 0, -1, is now at 0 and 1. Looks like that. Oops. Okay, so this guy, y-intercept is now 1. X-intercept, still -1 and 1. Vertex is now at, kind of the vertex, is now at 0 and 1. Okay, so let's write this in piecewise notation underneath. So in piecewise notation, don't go too far on me, x squared minus 1. There's two situations. Okay, the first situation is, where was it positive? Where did the graph stay the same? So where do we not need the absolute value brackets? We can just drop them, because the functions, if you compare the two, they're the exact same line. Where did they stay the same? Okay, where? Okay, you're going to have more than one inequality here. So, where did it stay the same? Think about the original graph, that one to the left compared to one to the right. Where is it overlapping? When x is less than what value? When x is less than -1, and when x is greater than 1. Okay? Do you see, if you compare the two, that's where it stayed the same? It was already above the x-axis. It wasn't reflected. So if x is less than or equal to -1 or x is greater than or equal to 1. Those two situations. Okay? And then where was it reflected? Where did we have to multiply the y values by -1 to make them a positive y value? So did it change? Well, what's left? What's not highlighted? Between? Oops, that's not a curve. Between -1 and 1. Right? That's where it's reflected. So if x was greater than or equal to -1, what did I do wrong here? Equal to, thank you. So greater than or equal to -1, less than 1. That would be my piecewise. So if you graph the two on your calculator, to write piecewise, graph both equations. One with the absolute value, one without. So it helps if you make maybe one of them bolder and the other maybe a dotted line. So if I'm going to change this, there's a bolder line. Okay, here's my absolute value. So the red line is so this is my absolute value. Here's the original. So you can see, okay, where did I reflect it? Between -1 and 1, where was it the same? Right, graph both. You can compare the two. Let's try the next guy. If you want to use your graphing calculator, that's fine. Okay. So let's graph this. Y equals, so x squared, absolute value of, oh no, we want the original. -x squared minus 4x, take away 5. Graph that. Okay, how do I get points? Yeah, you can go to your table, or you can just push trace, works too. Trace 0 and -5. And I can go -1, enter. So -1, -2. -2, enter. -2, -1. -3. Now we can see that pattern, right? -4, enter. -4, -5. Okay, so there's the original function. So now let's graph the absolute value. So y equals math, oops, that's not math. Math, right arrow 1. So does anyone need help? Got it? Okay. I guess I could have asked you if you have a prediction of what would happen. But let's see. Is that a surprise?
No.
Why not? The whole thing was negative, so the whole thing's going to become positive. The whole thing gets reflected. So it's all below the x-axis. Again, you can push the trace button and then keep pushing an x value. So x, but you can just look. Let's just reflect it. So now +5. This would be a +2. +1, +2, +5. There is my absolute. Oops, I want it over here though, right? Wrong graph. Okay, so let's write the piecewise because this is a little bit different. We look at this guy. -x squared minus 4x minus 5. Right before we do that, what was the x-intercept of the first graph? And x-intercepts of the second graph? None, right? There was no x-intercepts. So there's no point where the graph is changing from positive to negative. It was either always positive, right? It was always negative initially. Y-intercept was initially what? -5, and now it becomes +5. So piecewise, there's only one situation. There's only one case. Is it the positive case or the negative case? Were all the y values initially negative or positive? Negative. So there's only one case. It's the negative case. Negative of -x squared minus 4x minus 5. If x was what? For what x values did it get reflected? Was it reflected? Yeah, all of them. It was reflected on all of them. X is element of the reals. The whole thing was reflected. Kind of boring, really. Not as exciting as the first graph. Okay, so we're just going to do a couple more sketching, and then that's technically this lesson. Okay, one more page. I'll do one, you do one? Okay. So sketching by hand. Find the x-intercepts. We're going to go through these steps. Find halfway between them to find where the vertex is and plug it in to get the y value. The vertex is below the x-axis, flip it up. Join the x-intercepts and vertex with parabolic shape. Okay, so x-intercept. Let's find with finding the x-intercept. How do we find x-intercepts? We set y to 0. 0 equals the absolute value of -x squared plus 2x plus 8. Make sure you don't write too big here. There's lots you have to write in here. Absolute value of 0. Do you need absolute value signs? Like if 0 is equal to the absolute value of x, do you need the absolute value sign? No. Okay, so we can just drop them. And the x-intercepts of the original are going to be the same x-intercepts as the absolute value. All right, so how do we find x-intercepts? How do we solve this? How do we solve any quadratic? Factor. So the first thing I'm going to factor out is the negative. Switch all the signs. Then we, numbers that multiply to -8, add to -2. 4 and 2, which one's negative? -4 plus 2. So x equals +4 and -2. So there's our x-intercepts. We can plot those. So that's where the graph is going to switch, right? That's where the reflection occurs on one side of it or the other. So -4 and 2. While we're at it, let's find the y-intercept. Uh-oh, it's too big. Can you stop doing that, please? I gotta zoom out. Okay, y-intercept. We set x to 0. So y equals absolute value of -0 squared plus 2 times 0 plus 8. Guess what that gives us? 8. Okay. Oh, man. 1, 2, 3, 4, 5, 6, 7, 8. Okay. So finding the vertex. Finding the vertex. We can find the vertex by averaging the x-intercepts. Do you remember this? It did show up on your one of your quizzes or tests, one of the two, right? Because the axis of symmetry is where your vertex is at. It's halfway between any 2 points that are the same. like on the same y value. So we want to average them. What's halfway between -4 and +2? What's halfway? Hello? There we go. Between 4, -4, is it -4 or +4? Oh, it's +4. Anyone else notice that? You knew it and you were right. Sorry. Today's been one of those days where my brain is gone. Okay, it's at positive halfway. Not +2. Average them. What's 4 plus -2 divided by 2? 4 plus -2. 2 divided by 2. 1. Okay? Look at it. So if there's a distance of 6, I just need to go 3 spaces. And that lands me at 1. I want halfway. Where's halfway? So halfway is at x equals 1. So to get the y value when x is 1, how do I get the y value when x is 1? Sub it in. Okay? Sub it in. So 1 squared is 1 times -1. It's -1. -1 plus 2. It's 1. 1 plus 8. 9. Okay? So the vertex is at 1 and 9. Okay? So if we know that's the axis of symmetry as well, right, for a vertex, then we know another point. When x is 2, what's y going to be? 8, right? It's symmetrical. Okay, let's think about this original graph before we finish graphing this. What you want to do is think about the original graph. Did this original graph before the absolute value open up or open down originally? Down, right? Why do we know it opened down originally? The a was -1. It would have opened down originally. So this graph, initially, I'm just going to do a dotted line, looks like this. And it really helps to sketch the original graph. And you can do that with your graphing calculator really easily. Okay, that's the original. So what happens when I take the absolute value? Where it's positive, it's going to stay positive, and where it's negative, it's going to flip and up. Okay, so if you graph this on the graphing calculator, it's going to look something like that. Okay, so that's our new function. And comparing the old to the new helps with your piecewise the most. Okay, we expect everything's always going to be above the x-axis when we take an absolute value. Everything's positive. So what's the domain of my absolute value? Okay, for range is y is greater than or equal to 0. For domain, the blue graph, x is an element of the reals. Okay, and the last thing we're going to do is state the piecewise of -x² plus 2x plus 8. So where did this graph stay the same? Where was it already positive y values? Where did it stay the same? Is it going to be when x is less than -2, greater than 4, or is it going to be when it's between -2 and 4? Between -2 and 4. Okay, so because this graph originally opened down, the positive y values were between these two. See, if it originally opened up, then it would be here and here. but it opened down. So, okay, and then where was it reflected then? So multiply it by -1. Now if x is, where was it reflected? Less than -2, or when x is greater than 4. Okay? So I'd like you to try the example too. So I want you to graph it, find the x-intercepts, the y-intercepts, the vertex, and state the piecewise. Okay? Give it a shot. You have to work with someone beside you, do that. You might have had your graphing calculator help you. So this is what your absolute value graph would look like. Yep. Where did I get what? X is 3? Oh, so if I just wanted some other points, so I wanted a point, like all I had was these ones. So I wanted another point, so I just subbed in x is 3 in to get another one. And so, because of the axis of symmetry here, if I know this one, I know that one. Yeah. I wanted another point. You could also use the trace feature on your graphing calculator, or just the table of values on your graphing calculator, just to get some nice points. So this is all the algebraic stuff. Right, you could also use your graphing calculator to help you get all these things. Now the question is, would this graph originally open up or open down? Did it originally open up or down before the absolute value? Up. So it would have actually looked something like this, right? It would have opened up, originally opened up. So when you wrote your piecewise, did you write your piecewise yet? Yes? Okay. Where is it the same? Where did it not change? If x was what? Okay, less than or equal to -1. Or when x is greater than or equal to 2. Right, that's where it stayed the same. Where was it reflected? It was reflected, do you see that? Between -1 and 2. Okay, so check that you have the right inequalities here. The OR situation is not always on the top or always on the bottom. It depends on what the original direction of opening was. Okay, to see where it was reflected. Alrighty. So we're just going to start the next lesson, so tomorrow's not so hard on us. Okay?